we were at the last point where we were discussing about instance metadata and user data. So guys, well, let me share some of the real world example and where people are using these auto scaling and all that, and what are best practices they are using, how it is beneficial for them. So one of my recent customer, what they are into educational business. They are the biggest educational technology provider across US. I'm not sure if you have heard of the Blackboard name. What they do is they are purely into educational business, and one of their application is completely on immutable infrastructure. So when I say immutable infrastructure, they actually don't connect to any of the server. Whenever there is any problem of the server, suppose it gets crashed or any performance related issues or anything, they don't troubleshoot it. Because why they don't troubleshoot is because they'll spend more time troubleshooting it. What they do is they have auto scaling configured on more than 2200 EC2 instances. Whenever any server crash or any performance issues are there, automatically they get replaced with the new server. In 2016, in reInvent, AWS has declared immutable environment, that this is where the application future is. This is where everybody has to move. That going forward, there won't be any human interruption within operating system or at the infrastructure level. Most of the things will fall under immutable infrastructure, where nobody is going to touch, nobody is going to make any changes at the operating system level. Either it has to be automated or nobody will access to it. So when I talk to them, I ask them, where do you store your SSH keys? The answer I had got was that we have deleted the SSH keys. We don't use them. One guy out of the entire application has few of the keys, but rest of the keys we have removed it. Because why do we need any keys? What they have, there is another service which is SSM. Using SSM, what you can do is you can make any changes at the OS level. Initially, the moment you launch any of the service, you integrate that SSM, you give that IAM access, which I have shown while launching the instance. You give whatever changes, whatever OS related changes you want to do, you inject those changes, and those changes will be done and performed within your operating system. Think about any typical scenarios. When do you actually connect to the instance? Either for troubleshooting, or to extract some of the logs, or to update any package. All this has to be automated. That whenever there are any updates, you actually update your images, you update your MIs. If anything, if there are any performance issues, those servers get replaced with the new server. If you want to make any customized detail, any custom changes you want to make across all your servers, across all your 1,000 servers, you make use of SSM. Or if you have any configuration management tool like Chef or Ansible, of course you have to point your keys to these configuration management tools. But the word where if you see in the traditional environment, there will be a lot of Linux teams, there will be Unix teams, there will be a lot of teams who will be fixing a lot of infrastructure changes or challenges, or they will be doing a lot of operational changes, or they will be spending a lot of time to fix and troubleshoot within operating system, right? That's the core purpose of Unix team, that whenever there is any performance degradation or something crash, you connect to the server, you fix it, you come out of it. But if you actually see where 90%, 70% of the biggest outages happened, they happen because of human interruption. So human interruption should be completely removed. Your manual interruption, changing things manually, should be completely stopped. They have close to 23,000 servers, and there is not even a single manual changes at the operating system level, at the infrastructure level. Everything has to follow the automation process, right? So this is where why people are saying that there will be a lot of reduction at the operational jobs, because if one customer can run it, and these things are not, new in the market. One customer has published it, AWS has shown it. A lot of customers, they attend their events, and they also replicate and try the similar set of job. Right? Once they have these models implemented on their environment, they no longer need operational teams specifically for AWS or cloud team, right? For their traditional infrastructure, they would still require it because it's still meant and designed in older way of doing it. Still, it is not cloud ready. And to reach to immutable infrastructure, to reach to all these terminology, they need years of effort, thousands of hands to help on that. I was talking to one of the Gartner analysts some time back, and what they were saying that by 2021, cloud adoption will be mandate for every organization, which is at the moment, and machine learning and artificial intelligence is going to replace a lot of jobs. The organization where currently I'm working on a product where the service desk team, whatever the issues they work on, we are trying to replicate that. Instead of service desk agents answering and solving the problems, let bots solve the problems. We are implementing a lot of machine learning in that, so that, taking the lot of data, reporting data and ticketing data from the service desk, which actually technical people, currently they are human. We are training the bot that, so that whatever help technical agents are providing, the same help can be provided by bot. So bot training is going on at the moment. The moment bot is completely ready for it, the service desk team will be, at least there will be 80% of reduction in the human. Currently it's a 22 people of team, probably that will be reduced to 3 people or 4 people. Rest everything will be trained to bot. Instead of people answering questions, those bots will answer the questions. So that's where things are moving. Cloud, artificial intelligence, machine learning is not something very new to the market. A lot of organizations have already implemented it, and rest of is in process of implementing it. Okay. So coming back to the topic, auto-scaling and AWS auto-scaling groups. These are the 3 steps you do the moment you plan for auto-scaling. You create auto-scaling group where you categorize the group. Suppose for production servers, you create one auto-scaling group because production server may have different policies. Because it is a critical environment, you may want that in my production server, I want to set a condition that whenever, even if my CPU is utilized close to 60%, let auto-scaling add more servers on that. But for testing and dev environment, you want that load goes up to 90% or 80% because it's again one critical environment. Okay, so first step will be you create auto-scaling group. You categorized your instances. All you want to place the similar set of policy. Within that group, you define the minimum and maximum number of servers. Why we define that? Just to have, even if my server gets compromised by anyone, still I have those limits configured. Right? And then we define the desired number of running instances, minimum number of running instances which you want all the time up and running. Second step, what you will do is you define the launch configuration. In launch configuration, you define which servers will be added from. You define your AMI, you define your image. From that image, whenever there is any addition of the servers, whenever your environment needs to be scaled up, it will keep on adding servers there, but using the image you point there. Okay. You define any user data or anything is required, any customized script which is required, you define here. Then you define the scaling plan. In scaling plan, you define the specific plan and schedule, and if you have any custom jobs to be added to it, all those things you define in your scaling plan. When and how to scale, this is also you have to define. You will define the threshold, number of threshold, that hey, whenever my CPU goes beyond 70% or my network traffic goes high more than 70%, keep on adding new servers there. Scaling down, the way you define the scale up, similar section you will get for scale down in the same where you define the scaling policy. That while scaling down, do you want one server to be removed, or you want a set of servers to be removed from there? CloudWatch is something monitoring tool which will be added as part of it. Will retrieve the resource metrics. When I say resource metrics, it will be your it will fetch your CPU usage or incoming network traffic. So based on that, your threshold will work. The moment your CloudWatch will report that your server is consumed more than 70% of CPU, new provisioning request or scaling request will be triggered to add new server there. The alarm changes its state when the value of the metric breaches a defined range and maintains the changes for a specified number of periods. You can also define there that if CPU is going for 1%, or if it is constantly remain 70% for 5 minutes, then add, because sometimes you will see very short peaks that within 1 minute your CPU has gone 75 and again it came back. So you also can define those minutes there, that if your CPU load remains on peak more than 70%, and you can also define that add one server, or you want to add servers in fleet. Suppose 3 servers are there, and whenever load is high, what you want that another set of 3 servers should be added whenever CPU goes high. So that also you can define in the scaling policy. Planning your auto scaling group. You have to define how long it takes to launch and configure server. So you have to test it thoroughly, that whenever new server is being added. So one of my customer recently, what they have reported? They have reported that we have auto scaling implemented, we are into immutable infrastructure, but we are running into a lot of operational issues. And most of the time my servers reports a lot of downtime, that when I have asked them for reporting data and some of the reports, so the reason why they were facing a lot of downtime, because their application was so sensitive that whenever this transition happens, whenever a new server takes up the existing load, during that time, one script was running to update to make the recently added server get synced with the dynamic configuration. And whenever that update used to get triggered, And during that time, if any customer is fetching some query from that product, they used to get downtime. So we worked on that script, and that script earlier, it was updation part was taking 2 minutes. Now it is 1 minute, but still customers are reporting. So what they have done, they have they are working on a script which will not allow any auto scaling to be triggered in production hours. If there is any, and they are seeing a lot of data hitting on it, they will take the downtime from customer, that 1 or 2 minutes, the new servers will be added to it. They will send a communication to customer that, hey, this is the time when auto scaling will be triggered and new servers will be joining in. So you might face some latency or some minutes of downtime. So it's not that every application is ready for immutable infrastructure, but yes, people are trying for it, and there are applications which are completely into immutable infrastructure. It's no more myth that none of the applications can reach up to that state. There are applications which are running in production, and they are into immutable infrastructure. Okay, so what metrics have the most relevance to your application performance? If you have to evaluate your application, that what is the component you need, which may bring down your application, which may bring down your running application. Either it is network or it is CPU. You have to choose which one is the critical. If you choose that CPU is more critical because it is actually processing all your application logics, what you can do is you can define the threshold for your CPU. What existing resources such as EC2 instance or AMI you might want to use as part of auto scaling, you have to define whenever new server joins your stack, it should take the minimal time to take the existing load, pointing to the load balancer, syncing with the dynamic data. You should work on reducing this as much as you can. Then how many availability zones you want to do the auto scaling group to span? Auto scaling in single availability zone, auto scaling itself will not allow you to do that. Because at the same time, you are working on to scale a lot of servers, to scaling up your environment. At the same time, what you are doing, you are spanning, you are increasing your server within the same availability zone, within the same data center. What happens if that data center itself is down? Do you still have your scalability plan? No, your scalability plan fails if you have all your workload running in single availability zone. So whenever you are defining anything under your load balancer, your auto scaling group, you have to ensure that you are distributing all your workload into multiple availability zones. Yeah. The role you want to auto scaling to play in your application, you can define any custom scripts if you want to define whenever new workload is coming, or if you want some workload to pick up some of the dynamic files and to run some custom scripts, you can define that. Load balance your auto scaling group. Distribute incoming web traffic automatically, that anyways your load balancer is going to do. Single point of entry for your application. For higher critical application, sometime let me go back to my diagram. You will also see some of the very high critical application that they will have multiple load balancers. Why they will have, we are talking about to avoid any single load balancer in any single point of failure. At the same time, our entry point itself is running on one load balancer. What if this load balancer itself fails, right? To achieve this, what you can do is, but this is a managed services given by AWS, so they ensure and they keep on checking from the backend whenever there is any performance degradation. They fix that, but still, if you have some very high critical application, you can have two load balancers different running into two different regions. You can run it in Singapore, one load balancer, and secondary you can run into US. On top of that, what you can do is you can set up Route 53, which is a DNS service provided by AWS. Here you define the Route 53, which will distribute the load, which will have connectivity from load balancer 1 and load balancer 2, and it will perform the round robin. Whenever your load balancer 1 is not available, it will switch the traffic to US. Okay, so here also you have to replicate the entire setup in different regions. Okay, but you will not see this design as very common design, but people who have running some banking based application or very critical application, they will go for such scenarios. Single data about your load balancer and EC2 instance to Amazon Cloud Watch. You have to define the Cloud Watch has to be enabled so that it gets all the matrices from your auto scaling group. Your ELB, to scale your application, you have to define set of servers, number of servers which will be added as part of your scaling group. Use connection training. Understanding auto scaling cooldowns. So here cooldowns is something, the cooldown and warm up time is something whenever new instance comes up and it becomes a part of your application, how much time it is taking to pick up that application, to make that server available and to come up to the same state where rest of the servers are running. That is also you have to define. Next option can be your you also have to plan your cooldown so that whenever any new instance comes up, how much the cooldown and how much cooldown are you can afford that cooldown. Okay, so cooldown could be 2 minutes or 3 minutes or sometime more than that. So you should have a policy that while the new instance is coming up or it's going down, then you are able to afford that downtime. This is how auto scaling lifecycle works. This is your CloudWatch event. Then here, this is your auto scaling group. It triggers an event that I need CloudWatch reports that new instance is needed because ELB and the reporting metrics have reported that instance is running more than 70% of CPU. Then scale out event gets generated. That event generates a new instance, and then that instance gets added to the auto scaling existing auto scaling group. Okay. Then once you have suppose your performance again came back to the normal, another events get generated. What it does, it generates another event for termination of the new event, and then it goes here and terminate the event, terminate the instance, because it has got new metrics from CloudWatch, which is a monitoring tool by AWS, that hey, performance have come back to normal. Now let's remove that instance. This is how lifecycle hooks works. Suppose you want to run any custom script or you want to extract. Suppose you have a use case that whenever auto scaling is removing any instance, I want to fetch the latest log files, and I want that to be stored somewhere in my storage. What you can do is there is a lifecycle hooks policy as part of auto scaling. What it does is it will hold your instance for 30 minutes or 40 minutes, whatever time period you will define before it gets removed or it gets terminated by auto-scaling group. What it will do is, first it will let your script run, right? It will let your script run that let me forward my log files to some storage, and then I will go down. Then I'll get terminated. Okay. So lifecycle hooks is something which hold your instance before addition or before termination. If you want to run any custom scripts or custom action, you can define that. Let me show you it here. Suppose this is the instance which is in Reddit, and all of these two servers have came down into 50% of CPU. Okay. Now event has generated that third server needs to be moved. Okay. Because you are back to the normal, your CPU is running into the 50%. Now event has been triggered that remove this third instance because it's no longer needed. These two folks have taken over the 50% workload and their application is running absolutely fine. But this instance was having some of the log files. Consider config 1, config 2, config 3. I want to extract these log files and I want them to store somewhere in my storage, log S3 or any object storage. Okay. What lifecycle hooks will do? The moment the termination command will be fired from auto-scaling group, that hey, go ahead and terminate this. Here, it will first hold your instance. That hey, wait, you want to terminate me, but hold on, I have to finish certain jobs before I get terminated. And you can define the time of that script. Suppose your script takes 30 minutes of time to transfer these config files here. You can hold, so that lifecycle hooks will hold this instance for 30 minutes, and it will allow this instance to send these log files to your storage system. So the moment it will transfer your 1, config 2, config 3, then and your 30 minutes window gets over, then this instance will be terminated. I hope it's clear, right? So these are custom actions. You can actually hold the instance while it is being added or while it is being deleted to perform any of the custom action. Okay. Introducing bootstrapping. Bootstrapping is something whenever your instance comes up, install latest software. So now if there is this topic is debatable, like why do we have to install latest software on the fly whenever instances are being launched? Why can't we update the image and then launch the instance? So suppose I'm installing one package to my instance. Suppose I have created one image. In that image, I have installed Apache, I have installed Java, all these things I have updated. But is it really possible to keep on updating them every now and then? Either you update the image or you update the servers for regular patches. If you see the Windows environment, Microsoft releases a lot of new patches every Tuesday. So even if you have created a server from image, then also you have to keep on updating your servers which are already running every Tuesday. Otherwise, you might miss the security patches and all that. So for those kind of use cases, you should not hard code them as part of your image. What you can do is you can build one repository. In that repository, you all the patches from Microsoft, and then you take the downtime from your production owners, and then you deploy those patches to your running instances. But wherever you see the possibility that Apache is going to release its next patch in another 6 months, for those kind of use cases, you can update that package as part of your image, and you can keep on launching the servers from that. Copy data from S3, suppose of the log files or any application dependency has some files stored in your storage, and you want that data to be added as part of whenever your instance comes online. It becomes available. Or you have certain services like you have installed some monitoring agent, and by default it does not start automatically whenever your server comes up. So you can pass that script as part of your bootstrapping in your user data, that whenever my instance comes up, run this script, so that even if my script is in stop state, this process is going to invoke that script and my script will continue. Update packages, you can also run supposed to update any server, you run yum update -y, which will fetch the recent update from the repository and update all packages required for your application or your operating system to run. Suppose it has downloaded all those packages and after that mandatory reboot is required, you can also add that command as part of your script. Open port 80, you want to open port 80 so that this application server becomes available for rest of your servers. You can make that part of your script. Register with load balancer. Whenever the moment all these things are done, let your server be added as part of your load balancer. Mount devices. So mount devices is something, suppose whatever the primary volume will be of your EC2 volume, that will be by default mounted to your EC2 instance. But if you attach for more additional devices, for more additional storage, or more additional volumes to your instance, you have to write a script to mount them. By default, they won't be mounted. Okay. Bootstrapping tools, either you do it using Bash or PowerShell, Bash for Linux, PowerShell for Windows. Configuration management tools, you can use Chef or Puppet, or Amazon OpsWorks, which is again a management service provided by AWS. At the back end, this OpsWorks uses Chef. Metadata and user data, we already have seen. Probably tomorrow I'll add some of the random script and I'll pass when I'm launching one EC2 instance, and will verify that if those packages have been installed in my EC2 instance. Metadata is something, if you want to fetch any details about your EC2 instance, this is the API link to fetch any data about like instance ID, IP address, host name, everything. All that data can be fetched using this link. It will fetch like host name, AMI ID, instance ID, public, private DNS, availability zone of your EC2 instance. In user data, you can pass up to 16 KB of text. User data, this is sort of user data which you can add. This is the script which you can add as, as part of your user data while launching your instance. So if this is the script, if I will paste this script as part of my user data, it is going to install HTTPD, which is Apache server. First, I have to give this command to initialize, to tell that, hey, this is shell script. And then I will give yum install -y HTTPD, which is Apache server, and then I'll give MySQL server. So it will deploy all these packages to my server. After that, I'm giving another command that associate address. associate this address to my instance. So this is also you can do. Where I'm passing it into user data section while launching the instance. The moment you launch the instance, that passes to user data goes to metadata service, and then those packages go to instance, and then your script gets executed within your EC2 instance. Why we do the bootstrapping, why we do the auto scaling, why we do the immutable infrastructure, just to have well-defined automation in place, less fingers, less mistakes. It brings high availability with self-healing. You have not made some team sitting who are monitoring and who are doing the scaling and descaling manually. It's fully automated. Audit and manage your state with this time and effort. Scale, manage large scale deployments and drive auto scaling. Automatically it happens without any manual interruption. Whenever there is any peak, it adds the server. Whenever there is performance is normal or it requires less resources, automatically the resources will be deallocated from that. Security, you get instance locked down by default. You can correlate with the example which I have just shared. If you don't have SSH keys distributed across your developers, you have you have less chances of your server getting compromised, right? It is very flexible. It allows you to write shell script, PowerShell script, Chef and Puppet and OpsWorks. These are the configuration leader, the configuration management tool, which provides and support services. So it can be fully automated and supported while infrastructure is being launched within your operating system. Everything you can automate. Yeah. Okay, so I think we are close to end of the time of today's session. Tomorrow we are going to talk about storage and networking, and we will also touch upon some of the templates. I will show you how CloudFormation template looks like, which is actually your infrastructure as code, and we'll touch upon a few more components in tomorrow's session. Guys, please share your feedbacks. How was it today? And if you want anything to be added in tomorrow's session, you can probably share those feedbacks. I will go through them in my offline. S3 will cover tomorrow. Thank you, guys. I will check for the recording, how much recording has been done. I will publish the link as it is done. Thank you. You can also post your comments in the WhatsApp group, which is there. I think most of you are added there already. If somebody is not there, I can probably post the link here in chat, and you guys can add yourself there.